Hello everyone, my name is Joe Squarson, channel's called Ethernet Wink. Merry Christmas, because the day I upload this, it will be Christmas, so hope everybody's having a good holiday. I hope that you guys are spending it in a way that you're enjoying. Yeah, just hope that you guys are having a good one. It's Christmas, it's day 25 of the Advent of Code, so it's the last episode. This series was a lot of fun to do. Sometimes it took a lot out of me, and was a bit of an ordeal for me to get to it, but totally okay. We're through it now, and I hope I provided you guys with some great value. It is Christmas at this point. When you're watching this, not right now for me. It's still Sunday for me. It's the 22nd when I'm recording this. But yeah, a number of you guys have asked about Discord servers. A Discord server, like for me, like to start one, for everybody to start a community. I think it's a great idea. I'm probably going to start one when I'm closer to launching a product that I want to launch. So that way, it's like if you guys are using the product and you like it, even my thing with Luxago, why not? But if you guys are using that product and you just have questions, you just want to request a feature, you just want to let me know something, then you guys could just hit me in the Discord, right? It'd be, I think it'd be pretty personal, it'd be pretty cool for you guys to just do it like that. So yeah, this is my X. You guys make sure to follow this when you'll get updates on here before anywhere else. And this is my algorithm with Luxago. If you guys like to actually trade, it might be a good thing for you to check out. Obviously, it would help me out a lot, but no issue if you don't want to. All the details will be in the description. So, let's hop into the code that we're going to make today. So we're going to implement a Gaussian process regression with kernel, plot predicted versus actual. So in case this is your first time watching these Quant Finance Advent of Code videos, let's go over everything before we get down to the Gaussian process. So we're getting our stock data through this function. It will attempt to use a cache to see if we have a memory hit before we try to read it from a CSV or do an API connection for it. It'll just try to get it in the quickest way it can before trying to do something slower. Once we get our data, this will return a dictionary, so for all the tickers and data frames in there, copy our data, get our log returns, drop the NA, get our log returns as NumPy array, and then split it up into X and Y data. So just make a sequence of it, split it up into X and Y, so that way we can split it up into training and testing, scale it, shape it, get all that nice, and then we can actually start the Gaussian process. So I do have a little script over here just to make sure that I don't lie to you guys. So yeah, I scrolled past it. Here it is. So the radial bias function is what RBF stands for. And this length scale is a smoothing factor for it. But on every call, we're computing the pairwise squared distances between all of the points, and x1 and x2, getting those distances, and then this is the RBF kernel formula. Kernels in linear algebra represent the null space of a vector space, so that's why they could be useful. So yeah, they're going to be used in our Gaussian process regressor. So it needs a kernel, it needs an alpha just for some stability in everything, and training values, and K inverse represents the inverse of our covariance matrix. We're going to get there in a second though. So we're going to fit it. With our fitment function, we just need x train and y train. We really just need x train. Because x train is actually what gets used. So with our kernel, we're going to call it, and this will end up calling this. Yes, we're calling it with x train twice, but this is pretty much like x train I, x train j. Like it'll compute the distance between all the points in them, so that way we can get the null space that x train represents. And then we're going to add our alpha to it and multiply it by np.I, which returns a 2D array with 1s in the diagonals and 0s everywhere else of the length of our x string. That will give us our covariance matrix. Covariance matrix represents the variance between all of the different points in our data set. Now we're going to get the inverse of the covariance matrix, because that's what we're going to use in our predict function. So in our predict function, we're going to see the covariance between, well, x test. It's a little vague. I don't really know why I called it that, because this is going to be what we're actually going to use to predict. So our x test we're going to see the distances again in our kernel, so we're going to get the null space for that. And then the predictive mean is going to be ks transpose. This represents matrix multiplication in NumPy. So our ks transpose multiplied by k inverse multiplied by our y train, which is up here. And that will return our prediction. So we can just fit it, predict it, plot it, and that'll be all. So let's see what the results will actually look like for us. Oh, it went on my other screen, but that's all right. Bring it over here, and here we are. This is how it actually look for us. So seems to be all right. Seems to be decent. Sometimes it's pretty damn accurate, actually. So could be pretty cool. Could be obviously, and this is also predicting log returns, right? So it's just really predicting bullish return, positive return. So yeah, that's really all that's going on here. This code could be great because something I'm even realizing more as I'm just explaining it is it would be pretty damn hard for this to be overfit because it kind of has this persistence in this memory up here of our Y train in our fit. So it could be really, really cheap to keep on fitting this pretty much. Keep on fitting it so that way to new data. It'll be really cheap to do that. It's not like retraining an entire neural network. So that way every prediction has a more kind of dynamicness to it. And so that way over time it'll just be way harder to overfit this because it's way cheaper to keep on training it as opposed to something like a neural network or a decision tree or anything like that. But yeah, that is going to be the final video for the Quant Finance add-on to code. Ending it with some Gaussian process. Excuse me. Ending it with another regression model. It's stepping forward with the kind of linear algebra aspect of it. Do more with less. All you really need is a covariance matrix and some data and a kernel. So some null space, covariance, and you can get a lot done. So yeah, that's all for Quant Finance add-on to code, guys. I got a tickle in my throat like you wouldn't believe. But yeah, I hope that you guys enjoyed this series. Hope that you guys learned a lot. Hope that you guys are glad you watched it. Yeah, everybody have a great Christmas. Everybody have a great New Year's. I will see you guys probably in the New Year. So yeah, everybody have a good one, and I'll catch you.